Hello everyone and welcome back to our Petrophysics course. In the previous part, we talked about water filling and capillary pressure. We learned that reservoirs contain tiny pore spaces and these pore spaces are initially filled with water. But now comes an important question. If the pores are already filled with water, then how does oil and gas enter the reservoir? And more importantly, how does it push the water out? That's what we are going to understand today. In this part, we will discuss two more important concepts: hydrocarbons migration and drainage process. Don't worry, we will understand both concepts using simple everyday examples. So let's begin. So, where do hydrocarbons come from? Any idea about that? Before we talk about migration, let's first understand where hydrocarbons come from. Oil and gas are generated from organic waste sources rocks. Over millions of years, buried organic matter is exposed to increasing temperature and pressure. Under the right condition, this organic material can transform into the hydrocarbon. But the hydrocarbon don't necessarily stay where they were generated. They can move through the subsurface. This movement of hydrocarbon from the source rock toward a reservoir, maybe we called is called hydrocarbon migration. Think about something very simple. Imagine you have spilled a little oil and sponge. This oil does not always stay at exact spot where you drop it. It can slowly move through the connected spaces inside the sponge. The subsurface is much more complicated, of course, but the basic idea is similar. Hydrocarbons can move through connected pore spaces and fractures in the rock. So, why do hydrocarbons move? Now you might be wondering, why do hydrocarbons move at all? There are several factors involved. One more factor is buoyancy. Oil and gas are generally less dense formation water. So when hydrocarbon enter water filled pore spaces, they tend to move upward because of buoyancy. Here's a some example. Imagine putting a few drops of cooking oil into a glass of water. What happens? The oil moves upward and stay above the water. Why? Because oil is less dense than water. A similar density relationship exists between hydrocarbons and formation water underground. Of course, underground rocks are not an open glass. Hydrocarbons have to move through tiny and often complicated pore spaces, but buoyancy provides an important driving force for their movement. So, hydrocarbon migration is basically the movement of oil and gas through the subsurface. There are two important stages and that we should know about that. Uh, Primary migration and second is secondary migration. Primary migration refers to the movement of hydrocarbon out of the source rock. After leaving the source rock, hydrocarbons may move through carrier beds, faults, fracture, or other connected pathways. This movement toward a reservoir is called secondary migration. Let's use a simple example. Imagine a house where water is coming from a small tank. The water first leaves the tank through a pipe. Then we travel through another connected pipe until it reaches a storage container. Think of the source rock as the place where the hydrocarbons are generated. This connected pathway acts like the pipes and the reservoir acts like the storage container. This is a simplified example, but it helps us understand the basic idea of migration. Now let's imagine that hydrocarbons have reached a reservoir rock. Remember, the pore spaces were originally filled with water. So now we have a situation where hydrocarbons are trying to enter pore spaces that already contain water. This creates a displacement process. The incoming hydrocarbons begin to displace some of the water from the pores. This process is called drainage. And this is one of the most important concepts in understanding reservoir fluid distribution. Let's make it very simple. Imagine a glass of full of water. Now slowly pour oil into the glass. The oil does not simply disappear. It occupies space and pushes some of the water away. Inside a reservoir, something similar happens. But instead of a large glass, we have millions of tiny pores, and instead of pouring oil from the surface, hydrocarbons are moving through the rock. So, what exactly is drainage? In simple terms, the drainage is the process in which the non-wetting phase enters the pore system and displaces the wetting phase. In many conventional reservoirs, water is wetting phase and hydrocarbon behave as a non-wetting phase. As hydrocarbon enter the pore spaces, they gradually replace some of water. So the water saturation decreases. While the hydrocarbon saturation increase, let's use another everyday example. Imagine a kitchen sponge and that is completely soaked with water. Now squeeze some oil into the sponge. As the oil enters the sponge, it occupies some of available spaces and pushes some water out. Again, a reservoir is much more complex than a sponge. But this example gives us the basic idea of fluid displacement. But there is something very important to remember. Hydrocarbons do not enter every pore at the same time. Why? Because reservoir rocks contain pores of different sizes. Some pores are relatively large, while others are extremely small. The smaller the pore, the stronger the capillary force can become. So hydrocarbons may enter the large pore more easily, while some smaller pore can continue to hold water. This is one reason why water is not completely removed from a reservoir. Some water remains trapped inside the smaller pore. This remaining water is related to the concept of cornet water, which we will discuss in more detail in the next part. So remember, large pores and small pores do not behave exactly the same way. The size and connectivity of the pore system is strongly influence how fluids move through the reservoir. Now let's put everything together. At the beginning, the reservoir pores are mainly filled with water. Then hydrocarbon begins to migrate toward the reservoir. Because hydrocarbons are generally less dense than water, buoyancy helps them to move upward. When hydrocarbon enter the water filled pore system, they begin to displace water. This is drainage process. As drainage continues, hydrocarbon saturation increases and water saturation decreases. But remember, some water remain behind in the smaller pore and less accessible part of the rock. So the reservoir does not simply change from 100% to the 100% oil or gas. Instead, we have a gradual change in fluid saturation. And this gradual distribution becomes extremely important when we evaluate our reservoir. Now let's imagine the entire process as a simple story. Millions of years ago, water occupies the pore spaces of newly deposited reservoir rock. Later, hydrocarbons are generated in a source rock. Those hydrocarbons begins to migrate through suitable pathways. Eventually, some hydrocarbons reach a reservoir. Because hydrocarbons are less dense than water, they tend to move upward. As they enter the reservoir pore system, they begin to displace water. This is drainage. But the displacement is not complete. Some water remain inside the smaller and less accessible pores. Eventually, if a suitable trap is present, the migrating hydrocarbons can accumulate, and that is how we move from a water-filled rock toward a hydrocarbon-bearing reservoir. So let's quickly summarize what we learned today. First, hydrocarbon migration is the movement of oil and gas through the subsurface from their source toward a reservoir. And second, buoyancy. Buoyancy is important driving force because hydrocarbon are generally less than formation water. And third is when hydrocarbon enter a water-filled reservoir, they begin to displace water. This displacement process is called drainage. And finally, drainage does not remove all the water from the reservoir. Some water remains in smaller pore and other parts of the pore system. So, if you remember just one thing from today lecture, remember this: hydrocarbon enter a water-filled reservoir and progressively displace water, but they do not remove all of it. In the next part, we will take this story one step further. We will learn about hydrocarbon trap, connect water, free water level, or FWL, and the transition zone. This concept will help us understand where oil and gas water actually sit inside a reservoir. Thank you for watching. Thank you so much for watching. And remember, in your praise, if you found this lecture helpful, don't forget to like the video, subscribe to the channel, and turn on the notification bell. I will see you in the next lecture.